Hi friends, Mrs. McBride here again. I wanted to talk to you today about how things become charged, but before I start, here's a quick joke for you. What did the Dalmatian say after lunch? That hit the spot. All right, there are four main ways that objects become charged. The first one is charging by friction. The other one is called separation. The third one is called conduction. And the last one is called induction. Now I gave you the information about induction, but these sort of go in order of importance. So we'll start with, let's start with friction, okay? So if we were in class, I would show you, okay, here's a balloon, and here's me. Nice, wonderful hair, okay? If I take that balloon and I rub it on top of my hair, here's what you would see, okay? Maybe I wouldn't be smiling. Maybe this would be more like meh. Okay. And then what would happen to the balloon? Okay, so we talked about in the last video that the way that objects become charged is by moving electrons. So when you take this balloon and you rubbed it all over my hair, basically what it was doing, it was scraping electrons off of my hair. Okay, so it's essentially the balloon becomes charged positively because it wipes all those electrons off from my hair. Now what happens to the charge on my hair? Well, if charge is conserved, then the charge on my hair becomes positive. Okay, why does the hair stick up? Well, we know that opposites attract and likes repel. So if all these individual hairs are now positively charged, then they're all going to repel each other because they all have the same charge. And we know that opposites attract and likes repel. Okay, so this would be an example of how by friction, again, two things rubbing against each other, you would get one object that's charged negatively and you'd get one object that's charged positively. Okay, now polarization works in a similar way. Let's say, for example, you take the same balloon that we just had, okay, and we've got some negative charge on it, and we bring it over to a wall. Okay, well, this wall is neutrally charged. Most objects are neutrally charged. Nobody really likes to sit there being charged, and that's why you find you shock things. If you've gained charge, you want to become grounded. Okay, and we'll talk more about that. So as I bring this balloon closer to the wall, what I find is that when the balloon is close, if opposites attract and likes repel, we find that the opposites attract and the likes repel. Okay, so we could take this balloon and we could stick it to a wall. Now if you have a balloon at your house, you should totally try this. If you take the balloon and rub it on your hair, so get it charged due to friction, and then you put this balloon near a wall, you'll find that it should stick. So you get both charging by friction and charging by polarization. Okay, polarization just means that we've basically taken all the positives and put them in one spot and all the negatives and put them in another spot. Now you notice that this right here is still neutral. Okay, it's just that by polarizing, putting all the charge on one side and all the negative charge on the other side, you've made it polarized or appear that it is charged. Okay, charging by conduction is the easiest. This just means charge by touching. Okay, so if you touch something that's negatively charged, you also become negatively charged, okay? And again, that's due to this sharing of charge or making sure that charge is conserved, okay? So if you get hit by lightning, lightning is just a whole bunch of negative charges or a whole bunch of electrons, you will also become charged negatively, okay? The last one is induction, and what this is showing is if I take something and I bring, so this is neutral, and I bring something that is negatively charged close to it. We see all the positives go on one side and all the negatives go on the other side. If we then take our finger and ground this, we would find that all of the negatives go towards the ground or go away and all the positives are left. Okay, so that would be a way that something could be charged positively. We don't really see induction a ton, but MCC says induction is important, so we will talk about it. But really, most of the time when you see something becoming charged, it's charged due to friction, rubbing together, charged due to separation, something that's neutral that acts as though it's charged by separating the charges, or conduction, charge by touching. Now here's what I'd like you to do. On the next page I have 9 questions for you. So I want you to pause the video right now and answer those 9 questions. In a second, I'm going to go over the answers to those 9 questions. I'll give you the answers first, and if you're content, then you can stop watching this video. If you have a question on one of the questions, then keep watching. Okay, pause the video and go ahead and do all the 9 questions on page 3. Hopefully you have done the questions on page 3. Here are the answers. Number 1, the correct answer is 3. When you put plus 5 and minus 3 together, you would find that there is 2 total, right? So if you just do positive 5 minus 3, you get positive 2 total. When those 2 separate, that means you're going to have positive 1 on each one. Okay, so question 2 says, how would you account for the charge that resulted in question 1? Well, what actually happened was 3 electrons moved from the negative 3 sphere to the positive 5 sphere. Okay. Remember, number 2 and number 4 are totally wrong because we know that protons don't move. Remember, protons are stuck in the nucleus and those don't move. Number 3, which of the following is incorrect about static electricity? Number 1 is incorrect because the charge on a single proton is not 1 coulomb, but it is 1 elementary charge, right? That's a big difference because 1 elementary charge is 1.6 e to the negative 19 coulombs. Okay. We didn't really talk about this, but number 4, the correct answer is 4. All of those would be good insulators. Think about what would you put a hot beverage in, any one of those things. Number 5, the correct answer is 3. When you become positive, it's because you've lost electrons. Remember, again, you can't gain or lose protons. Those are totally wrong. Number 6, the correct answer is 3. We did an example like this on the other page of how to convert a half a coulomb to electrons. So what you would do is you would take 1 and divide it by 1.6 e to the negative 19, and that would get you the number of electrons. So look back on the previous page if you have questions. Okay. A charge of 100 elementary charges, so that would be, the correct answer is 3. You would take 100 times 1.6 e to the negative 19 coulombs, and you would get 1.6 e to the negative 17 coulombs. Number 8 is asking which of the following statements is true. So if the rod is rubbed with the fur and the rod acquires a charge of negative 2 coulombs. Again, remember, 1 and 2 can't be right because we know that we don't gain or lose protons. So we're only down to choices 3 and 4. If the fur acquires a charge of negative, a neutral rubber rod is rubbed with fur and it acquires a charge, of negative. That means the rod must have gained electrons from the fur. Okay, if it became negative, that's because it gained electrons. And last but not least, which of the diagram best represents the charge distribution? What this is showing here is that charge separation. So if this is a big negative, we find that opposites attract and likes are going to repel. Okay. Again, this would be, these two are both neutral, but this is showing our charge separation. This is showing the wrong charge separation because the likes are attracting, and we know that that doesn't happen. Okay? Thank you very much, guys. Talk to you soon. Bye.